So today we will be doing another curve sketching problem, and the function is f of x equals 4x cubed minus 12x squared. So the first step I like to do, again, is to find the domain of the function. Notice that we can plug in any number for x, so the domain goes from negative infinity to positive infinity. Second thing I like to do is find any intercepts of the following function. So notice that there are x-intercepts and y-intercepts. The y-intercepts occur when x is 0. If x is 0, we get y equals 0, so the y-intercept occurs at y equals 0. The x-intercept occurs when y equals 0, so if we get 0 equals 4x cubed minus 12x squared. If you factor out an x squared, we get x squared times 4x minus 12, and we get x equals 0 as an x-intercept and x equals 3 as an x-intercept. The third step I like to do is to find any asymptotes, but notice that there are no undefined values, so there are no asymptotes for the following function. No asymptotes. So the fourth step involves calculus, and remember what we want to do is we want to find the derivative of f of x, set that equal to 0, and find the x-coordinate so we can use the number line test to determine any minimums or maximums and the intervals of increase and decrease. So first we need to find f prime x, and remember this is just simply power rule, so you bring down the 3, keep the 4 at front, and remember subtract 1 from the exponent, minus again, keep the 12, bring down the 2, and subtract 1 from the exponent. When we simplify this, we get 12x squared minus 24x. Again, we have to set this equal to 0, so we have 12x squared minus 24x equal to 0. In fact, divide everything by 12, so we get x squared minus 2x equals 0. Take out an x times x minus 2 equals 0. And notice that we have two answers now. We have x equals 0 and x equals 2. Since there are no undefined values, we only have two values to test. So we have to test x equals 0 and x equals 2. So again, let's draw a number line. We have 0 over here and 2 over here. And now remember, we have three areas to test. We have to test this area, and this area to determine the sign of what we get. So we can find out any maximums and minimums and the intervals of increase and decrease. So let's pick a number left of 0. Let's pick -1, and remember we have to test it into the derivative. So let's pick -1. If we plug it into the derivative, notice we get 12 times -1 squared, which is just 12, minus 24 times -1, which is a positive number. So we get a positive plus a positive, which is a positive. So we get a positive number here in an upsloping curve. Notice if you pick a number between 0 and 2, if you pick 1 for example and plugged it in here, we would get a negative number. So you have a negative number and we have a downsloping curve. And again, if we picked a number between 2 and right of 2, and pick like 3 for example, this would be 12 times 9, which is much bigger than 24 times 3. So again, this would be a positive number, and we'll be going straight up. So notice that we have two critical points. 0 is a critical point, and 2 is a critical point. Notice that since this makes a mountain, 0 would be a max, right, since it's making a mountain, and 2 would be a min, since it's making a valley. So from the number line test itself, you can tell whether the critical values you have are mins or maxes. If it makes a mountain, it's a max. If it makes a min, it is. If it makes a valley, it is a min. So after we determine our maxes and mins, we can now do our intervals of increase and decrease. If we label this end as negative infinity and this end as positive infinity, we can say that from negative infinity to 0, it is increasing. From 0 to 2 is decreasing. And from 2 to positive infinity, it is again increasing. So from the number line test and the first derivative test, we found our mins and maxes, and we did our intervals of increase and decrease. So the fifth step again is the concavity test. And if you remember, the concavity test means that we have to take the second derivative of the function, and we have to set that equal to 0 and find the x-coordinates so that we could use the number line test to find the interval of concavity and any points of inflection. So we know that the first derivative was equal to 12x squared minus 24x. So if we have to find f prime, this is again the power rule, and f double prime, equals 24x minus 24. Remember, we have to set this equal to 0, so 24x minus 24 equals 0. 24x equals 24, x equals 1. There are no undefined points, so we only have to test x equals 1. Again, draw a number line, put 1 in the center. Now we have to test the point left of 1 and right of 1 into this function to determine the sign. So let's pick 0, and if we pick 0, notice that we get a negative number. So we get a negative sign over here, and we have a down-sloping curve. Pick a number greater than 1. If you pick 2, notice we have a positive number. So we have a positive number, we have an up-sloping curve. Notice that the sign changes. So 1 is a point of inflection, P is a POI, and remember, negative means concave down, so it's concave down before, and then concave up after. So we can write our intervals of concavity. So if you label this as negative infinity, and this is positive infinity, we can say from negative infinity to 1, it is concave down, since it is negative, concave down, and from 1 to positive infinity, it is concave up. So again, we did our concavity test. We took the second derivative, set it equal to 0, found the x-coordinate at which that occurs, tested points left and right to it, found the sign, and understood that was a POI, and then did our interval of concavity. So before we actually sketch our function, I'd like to go over what we discovered. So the domain, we said, was from negative infinity to positive infinity. We said the intercepts, there were 3. The y-intercepts, y-int, happened when x equals 0, and that was at y equals 0. And the x-intercepts, we had 2 of them. That occurred when y equals 0, and the x-intercepts were, again, if I remember, they were x equals 0 and x equals 3. We had no asymptotes, so none. We had a max at x equals 0 and a min at x equals 2. And again, if we plug this point x equals 0, we can find the y-coordinate. So we had a max at 0, 0, and a min at, plug in 2, we get 2 cubed is 8, 8 times 4 is 32, minus, again, 2 cubed is 8, 32 minus 12 times 4. So 32 minus 12 times 4 is 32 minus 48, which is negative 16. So we had a min at 2, negative 16. Intervals of increase and decrease, we know from negative infinity to 0, we had an increase. From 0 to 2, we had a decrease. And from 2 on to infinity, we had an increase again. POIs, we had 1 POI, and that POI occurred at x equals 2. And again, if we plug this into the function, we can determine that at x equals 2, y equals, so we can say this point was at 2, 2 again is 8, 8 times 4 is 32, 32 minus 48 is negative 16. So that POI occurred at 2, negative 16. And remember, point of inflection means there's a change in concavity. So on the interval of concavity, we said was from negative infinity to 2. It was concave down. Right? And from 2 to positive infinity, it was concave up. So now we are ready to actually sketch our function. So the first thing I would do is draw all our intercepts. So we have one intercept at the origin, and we have another at x equals 3, y equals 0, so that's right there. So now we have to use our intervals of concavity and intervals of increase and decrease to actually sketch this graph. These are the intervals of increase, and these are the intervals of concavity. So first, I would begin, to make it much easier, I would separate the graph by the intervals of increase or decrease. So it separates in the middle, so it cuts, since it's going from negative infinity to 0. So there's one part going down here, there's one part stopping from 0 to 2, so there's one part going down over here, and the rest is there. So there's 3 parts. From here, from negative infinity to 0, from 0 to 2, and then from 2 to infinity. So let's look at just from negative infinity to 0. So from negative infinity to 0, the slope is increasing, so it goes like that. And if you look down here, I gave you the intervals of concavity, it is decreasing, so it's concave down like that. So the only part of this mountain shape that looks like upsloping is this portion of it. So the only way that is possible, that can happen, is if the function starts down here and reaches the origin like that. This looks exactly like half the mountain, so that kind of makes sense. Now, if we look at the region from 0 to 2, if we isolate that, notice how the concavity is still down because it's negative infinity to 2, so the concavity is still downwards. However, the slope, the function is actually decreasing, so it's a negative slope going like that. Notice that the second part of the function mimics that decreasing slope, so it would look something like, go from 0 to 2, it would look something like that, right? That makes sense, because it's decreasing and it's concave down. And then, if we look at the third part, which is from 2 on to positive infinity, notice that it's increasing, so it's has a slope like that. And it's also concave up, so it looks like that. The part of the U that looks like going straight up is this part of it. So if we mimic that on the graph, remember we have to go through our intercept, so it would be going like that. Up, you had a max at 0 and a min